C382. Okay. So this lab goes with your digital communication subject. In this, you are going to do simulation experiments. Okay, it has been decided to go with a Python and simulate the following experiments. Okay, so first we'll see what is the way we are trying to evaluate you. Okay, so totally 7 experiments will be there. Okay, each day you are going to do one experiment, and in the morning 9:30 to 10 I will give the introduction about the experiment that you have to simulate in the Python. Okay, if you are comfortable with the MATLAB, that also welcome, you can do. Okay, so either Python or MATLAB you can do it. Okay, so 7 experiment, each day one, and first half an hour 9:30 to 10 you are going to have a elaboration about the experiment. Okay, and after the elaboration you are trying to simulate the things. Okay, once you are simulating, you are going to upload your program. Okay, don't upload as a screenshot. Okay, so once you are uploading as a screenshot, if you want verify, it's not easy to verify. Okay, so copy, paste and upload it. Okay, so the following things we are expecting from your side, that is you are expected to upload the document. Okay, whatever the thing available. So the theory began the experiment that you have to write it. Okay, if I say sampling, what about the sampling, how they are getting the sampling, what is the sampling frequency, what is the sampling theorem, okay, what is the spectrum, all the things you have to write the theory behind the experiment, and then what is the way you are trying to implement it, that particular algorithm. That should be in handwritten, that should be in handwritten. Then after simulation you will get some results. Okay, that you have to attach. Okay, combinedly these two you have to make it as a single PDF, and you have to upload in the AUMS before 6 p.m. Okay, the student has to upload the following documents on or before 6 p.m. on the same day. Okay, so first one, handwritten document, that is a theory and algorithm. Second one, what about the results you got. Okay, that the screenshot, the result should be a screenshot, the program should be the cut copy paste, that you have to attach. Okay, that you have to finally make as a PDF and you have to upload it, that you have to done before 6 p.m. every day. Okay, the evaluation pattern, preparation we are going to have a 30 marks. The preparation, whatever the handwritten document, theory and algorithm, that carries 30 marks. Okay, an experiment 30 marks. The 30 mark experiment, every day we'll call individually, we'll ask to run your program, we'll ask some question, based on that you will get, based on your performance we'll have evaluated for 30 marks. Okay, so preparation 30, that is handwritten document, will carry 30 marks. Simulation, the program, whatever results you got, once you got a result, how you got, okay, is there is any, and what about your understanding about the code. Okay, based on that you will get 30 marks. And evening 4:30 to 5 you will have a MCQ Viva in the AMS, maximum 10 questions or 15 questions will be available. Okay, that you have to answer. Okay, maximum 10 to 15 minutes only. For namesake I gave 4:30 to 5, 15 minutes MCQ in the AUMS. Okay, so this is for your continuous assessment, 80 marks. Each experiment will have 80 marks, preparation, experiment and MCQ Viva in AUMS. Okay, and for end semester it is Viva in through MST. Okay, it carries 20 marks, totally 100 marks. Okay, this is the way we are trying to evaluate. You have any clarification in this? Do you want any clarification?
No, sir.
No.
Sir.
Yeah, tell me.
Sir, can we like do first few experiments in Python and then switch to MATLAB?
I told that's up to you.
Uh,
Those are interested, they can go for MATLAB. Those are interested, they can go with a Python.
okay, sir.
Why? You don't know Python?
No, sir, but GS algorithm, I thought it would be easy in MATLAB.
Okay,
Matrix
it's not a
formation.
big issue. Okay.
Okay, sir.
Any other suggestion or any clarification?
Sir, so only aim, theory, and algorithm should be written, sir, and the rest of the things should be typed.
Aim, okay, what is the objective that you are going to write?
Yes, sir.
Then
Theory,
tools,
sir.
MATLAB or Python.
Okay, sir.
Straight away you are going to start based on the experiment. What are the things are required? The theory began that. Then you are going to write the algorithm. Okay. This one carries 30 mark. Okay. Next 30 mark, every day we will call you. Okay. You have to show your output. Okay. Based on the way you did the program, you are going to get a 30 marks. And evening 4:30 to 5, you are going to have a AMS Viva. Okay. That carries 20 marks.
Sir, to show the code, we'll be getting a call, no, sir? At what time will
Yeah,
that call be coming, sir? Like time?
After only we will try to make a call because we have to give sufficient time to complete our programs.
Okay,
Okay.
sir.
So try to do it individually. Don't try to copy the programs. Okay. Anything else you want to know? So now we will go for the experiments. Okay. So the same thing written here. CA continuous assessment preparation 30 marks. Okay. Experiment 30 mark, by you are 20, in semester 20, totally 100 marks. Okay. So these are the experiments we are trying to do. First one, what you are going to do tomorrow, it's an analog to digital conversion and digital to analog conversion. Okay, there are several ways available, but here I want more specifically the sampling, quantization, encoding. Okay, so for that you are going to take a three signals, sinusoidal, composite signal. For the signal, you have to find the frequency. Based on the frequency, you have to compute the sampling frequency. Once you found the sampling frequency, we are going to provide you with a different step size. Okay. Based on the sampling frequency, you are going to sample. Okay. Once you are getting the sample, immediately you try to go for sampled signal to original signal conversion back. Okay, that you do it. Okay, take a composite signal, find the FFT, from that you check the frequency, based on that you select the sampling frequency, based on the sampling frequency you sample the signal. Once sampling done, you take the sample value, use a filter or use a shifted version of sync pulses, you convert a sampled signal to original signal back. Okay, there are two methods available. Either you can design a proper filter. Okay, So pass your samples to the filter that is going to provide you original signal. That is the frequency domain representation. If you are trying to work out with the time domain itself, you try to get a proper sync for your sampling frequency. Based on the sampling frequency, you will have a sync. Okay, you get the sync, you shift the sync scale by your sampled value, add it. That is also going to provide the signal. Okay, so that also that you do it. Then once again you are going for a quantization. Okay, so take the sample value, quantize based on the different step sets. Okay, once you are doing the quantization, based on the quantization level, you are going for a encoding. Okay, and after encoding you are going to have a zeros and ones. Okay, the same thing from zeros and ones, once again you have to convert the original signal. Okay, these are the things you have to do for tomorrow. Okay, anyhow, I'll give you once again the explanation tomorrow. And the second experiment is a pulse shaping. Okay, so link is available here. You can go through the link that will give the program itself. Okay, but you try to understand, you try to implement it. Okay, pulse shaping. So what is the reason for a pulse shaping? We want overcome the bandwidth problem. Okay, if I go with the rectangular pulse, I have to go with the infinite bandwidth. It's not possible. So we are trying to limit ourselves to within a specific bandwidth. For the purpose, we are going for a pulse shaping. Here, more specifically, we are trying to target on a rise to cosine filter. The equation is given in the book. You can copy the equation. Okay, there is a factor called, there is a roll-off factor. You vary the roll-off factor. You try to get a different pulses. Okay, different pulse. Okay, then the receiver end, the matched filter. Okay, so you are going to design a filter. You are trying to design a filter that is going to reduce the noise effect. Okay, and the third one, you are going to have a eye diagram. Third one, you are going to have a eye diagram. Okay, from the pulse shaping, you are going to take the signals and you are overlapping one on another instead of plotting continuously. Okay, you will take a symbol duration. Okay, each symbol you are overlapping on the same axis, same time plan. Okay, okay, you will get a eye diagram. That program also available. Okay, so try to understand what is happening in the pulse shaping, what is the matched filter, what is the eye diagram. Okay, this is the second experiment. The third one, creating noise. So we create whatever signal available, we convert the signal to zeros and ones. Then we have to do the modulation. At present I have not given it. The modulation part I gave as a fourth experiment. Okay, but anyhow. So once you are doing the modulation, based on modulation, we are going for a pulse shaping. After pulse shaping, we are going for a passband modulation and we are going to send it. Okay, now in the channel we are going to have a noise effect that is given as a third experiment, AWG noise. Okay, we are trying to create a additive white Gaussian noise. Okay, so here variance is going to play an important role. Based on the variance, we are going to have a different SNRs or we are going to get a different noises. Okay, that we are going to generate, and then we are trying to have a channel, a Rayleigh fading channel. Okay, that I will teach you. Okay, so signal is transmitted and it is corrupted by the noise and it is corrupted by the channel effect that we are implementing at the third. Okay, and for understanding purpose, we are going to have a simple modulation schemes based on passband modulations. Okay, so these are the experiments. Then other things are simple thing: Gram-Schmidt orthonormalization, pre-coding. Okay, to overcome the problem ISI. Okay, so instead of going for a zero ISI, we are trying to have a partial ISI that we are trying to achieve with the help of a DO binary signals that we are implementing as a sixth experiment. And finally, whatever system we design for the system, we are calculating the error. Okay, that is the way the experiments are planned. So if you want, you can take a screenshot of this one. Okay, so you can prepare in advance, no problem. Okay. So if you have any question, you can raise. Otherwise, you'll wind up.
Sir, can you upload the document?
I told take a screenshot. I'm not uploading. That's why I told take a screenshot. Anything else? Any
No, sir.
questions? Okay, Raghunath. If you have no problem, you can leave.
Thank you, sir.
Okay.
Thank
Tomorrow
you, sir.
9:30.